Welcome back to Summarize Science. Today, we're looking at one of the biggest mysteries in modern astronomy, the gravitational wave event GW190814. This 2019 detection was unlike anything we'd ever seen before. It involved a 23 solar mass black hole colliding with a much smaller, 2.6 solar mass object. This smaller object was so strange it fell into the mass gap, making it either the heaviest neutron star or the lightest black hole ever found. So, how did such a mismatched pair form in the first place and then manage to merge? A recent paper set out to explore this very question. The researchers used a powerful simulation framework to essentially work backwards from the final merger all the way back to the system's birth. They simulated countless pairs of stars, evolving them through their entire life cycles. This included complex processes like stars swelling up and swapping material, and the violent supernova explosions that create black holes. Their goal was to find the exact starting recipe and series of events that would create a GW190814-like system. On page 6, a schematic shows the most likely formation story they uncovered. It starts with two very massive stars, one around 80 times the Sun's mass and the other around 22. After a few million years, the larger star swells up and engulfs its partner in what's called a common envelope phase, which shrinks their orbit dramatically. The first star then explodes, forming a large black hole, but it receives a relatively small kick from the supernova. Years later, the second star's turn comes, and this is where things get really interesting. When it explodes to form the second, smaller object, it gets a massive push, which the paper calls a lucky strike. As you can see from the data on page 7, this kick had to be incredibly specific. It needed to be large, perfectly aligned with the orbital plane, and directed in just the right way to not tear the system apart. Instead of breaking up, this lucky kick threw the new black hole pair into a long, egg-shaped orbit. This extreme orbit was the key, as it allowed the pair to radiate away energy as gravitational waves much faster and merge within the age of the universe. The researchers calculated that the chance of such a perfectly aimed kick happening is only about 20%. So, let's recap the big takeaways from this study. The extreme weirdness of GW190814 might not come from its parent stars, which were fairly normal for their immense size. Instead, its formation and merger were likely enabled by the violent and chaotic physics of a supernova explosion. The secret ingredient was a powerful, precisely aimed lucky kick that put the binary on a fast track to collision. What does this mean for the future? This method of reverse engineering a cosmic event provides a powerful tool for astronomers. By applying it to more gravitational wave detections, both common and rare, they can build a better picture of how binary stars live and die. It helps us understand the fundamental processes that shape the diversity of objects we see colliding across the cosmos.